Lesson 4, Determining Angles Using the Primary Trig Ratios. So in our last activity, we discovered some new trig ratios, and they were the sine ratio, the cosine ratio, and the tangent ratio. So here, I'll spell them out again. So sine, cosine, and tangent. Now we write abbreviations for these ratios. We call them sine with S-I-N. And we usually denote this by saying the sine ratio of a marked angle, theta, is equal to the ratio between the length of the opposite side divided by the length of the hypotenuse side. Cosine ratio is abbreviated COS, so the cosine of the marked angle is equal to the length of the adjacent side divided by the length of the hypotenuse side. And the tangent ratio, abbreviated TAN, tangent of the marked angle, is equal to the opposite length of the opposite side over the length of the adjacent side. And so these are what we call the primary trig ratios. They're like equations. You can solve for certain values. And on your calculator, you have them too. And I'll show you momentarily how they work. Now, to help you remember these three ratios, we have a little mnemonic called SOHCAHTOA, where the first letter denotes the name of the ratio. So sine, S for sine, C for cosine, T for tangent. And the other two letters represent the two lengths that you're going to divide. So the opposite divided by the hypotenuse, adjacent over the hypotenuse, and the opposite over the adjacent. So if you can remember this mnemonic, SOHCAHTOA, you'll always be able to remember the ratios for your primary trig ratios. So as I said, they're already programmed into your calculator. Okay, so you can choose some angles and you can compare them to what you see in the trig table. So if I go to the trig table, for example, and let's say I was interested in 10 degrees. So if I calculated the sine ratio for 10 degrees, so I'm going to take a calculator, and here it is. I'm going to, and so make sure your calculator is in degrees. So you have to see here the DEG or D symbol on your calculator. And if I hit 10 and I press the sine function here, sine, I get an answer of 0.1736. And exactly that's what you see in the table, 0.1736. You can do the same thing for the cosine. So if I hit 10 and the cosine function, I get 0.984. And that's exactly what you see here in the trig table. So this entire trig table that we looked at yesterday, that we had in our activity, has been saved into several functions in our calculator for sine, cosine, and tangent. Okay, so let's look at how do I find the measure of angle theta to the nearest degree. So this is good if this calculator is good if we had the angles, but what if we don't? What if we had to work backwards to find the angle? Well, you could use the trig table. So for the sine ratio, for sine theta equal to 0.5, well, if I looked at 0.5 on the table, 0.5 is located right there, corresponding to an angle of 30 degrees. So I can say theta, for part A, theta equals 30 degrees. Now, if I didn't have the trig table handy, I could do this in the calculator as well. The way you find angles in the calculator is to use the set of functions right below, the inverse functions. Sine, the sine with this exponent -1, it's not really an exponent, it's just the label, but this label says this is the inverse. So the inverse sine of my ratio. So I'm going to enter the ratio, 0.5, and I'm going to do the inverse sine, and the inverse sine will give me my angle 30 degrees. Okay. If I looked at B, the tangent of theta equals 1. So I look on my table, let's look at the tangent column. Where the tangent column is my third column. So where is it equal to 1? So if I go down, I'll see here it's equal to 1 at exactly 45 degrees. So I can go to my example and to the right, theta equals 45 degrees. On my calculator, I can do the same thing. So if I'm looking for an angle, I'm going to hit my ratio. So my ratio here is 1. And I do the inverse tangent to find the angle. So the inverse tangent tells me 45 degrees. Okay, so what about part C? What is theta when the cosine of my angle is 0.5? So if the cosine of my angle is 0.5, I can go to the second column here, the cosine column, and look for 0.5. And I'll find 0.5 all the way over here. 0.5, I circled it, and that corresponds to an angle, a marked angle of 60 degrees. So my answer here is theta equals 60 degrees. And I'll do part D on the calculator. So what's the angle, theta, when the sine ratio of that angle is equal to 0.866? So if I enter 0.866, and I do the, so it's, okay, oops, and I do the inverse sine, I'll get my angle, about 60 degrees. So theta equals 60 degrees. Okay, example 2. Determine each ratio and write it as a decimal to 4 decimal places. So again, the sine ratio, if you remember the SOHCAHTOA mnemonic, you can write it here for reference. SOHCAHTOA. Sine of the angle is equal to the opposite side over the hypotenuse. So if I look at angle C as my reference angle, the opposite side is 8, the hypotenuse is 17. So for part A, the ratio is sine of C is equal to 8 over 17. Look at part B, the cosine of angle C. Well, 15 is my adjacent side, and the cosine is the adjacent side divided by the hypotenuse. So the cosine of angle C is equal to 15 over 17. Then the tangent ratio is the opposite side divided by the adjacent side. So look at the opposite side, 8, divided by the adjacent side, 15. So the tangent of, oops, I made a mistake. This assumes the reference angle is C, but the reference angle is B now. So I'm going to make some changes here. So if my reference angle is B, then my opposite side is 15, and my adjacent side is 8. So the opposite over the adjacent is 15 over 8. I can express these answers as decimals. So 8 over 17 is 0.4705. 15 over 17 is 0.8824. And 15 over 8, 1.875. Okay, similarly, we can also calculate these other three ratios for D, E, and F. The tangent of angle C is opposite over adjacent, so it's going to be 8 over 15. The cosine of angle B is going to be the adjacent side over the hypotenuse, so 8 over 17. And the sine of angle B is the opposite over hypotenuse, which is 15 over 17. And you can also find the decimals to 4 decimal places. Okay, let's look at another example. Let's determine the measure of angle theta to the nearest degree using each primary trig ratio. So according to the angle theta, my marked angle, the 2 centimeters is my opposite side. The hypotenuse is 5.39. So I can use the sine ratio for theta to help me find that angle. So the opposite over hypotenuse is 2 over 5.39. So 2 divided by 5.39 equals, here's my decimal, and if I want to find the corresponding angle, I use the inverse sign. Make sure, again, your angle is in degrees. Your calculator must be in degree mode. So I do the inverse sign, I get an angle of 21.78, which I'll round to the nearest degree at 22 degrees. So angle theta is equal to 22 degrees. No need to write sine theta anymore. Theta is 22 degrees. Now, what if I were to want to use the other ratios? Well, I need to know the adjacent side. So what's the adjacent side? Well, I can find the adjacent side by using the Pythagorean theorem. So let's call the adjacent side the variable x. And I'm going to say 2 squared plus x squared equals 5.39 squared. So x squared equals 5.39 squared minus 2 squared, And then so x equals the square root of, well, let's calculate this. 5.39 times 5.39. And we know 2 squared is 4, so I'll subtract 4. And so I get 25.05. And I take the square root of that, I get 5.005. So x is going to equal to 5.005. And for most practical purposes, you could probably round that to just 5. Okay. So to find my cosine ratio, I need the adjacent side, which is 5, and the hypotenuse is 5.39. So 5 over 5.39. 5 divided by 5.39. And there's my decimal, 0.9276. And if I wanted to find the angle, you take the inverse cosine, and you should get roughly the same answer, 22 degrees. And my tangent ratio is going to be the opposite over adjacent, so 2 divided by 5, and that's approximately, well, 5 is not exact, but it's going to be approximately 0.4 as a decimal. Okay, so those are my ratios. You can also express the sine and cosine as decimals at the end if you continue calculating them. Okay, example 4. Determine the measure of angle theta using any of the primary trig ratios. So you can use any of them. So if I have the primary trig ratio of theta, if I have the angle theta marked here, 50 is my adjacent side, and 54 is my hypotenuse, and 20 is my opposite. So if I use the sine ratio, I have all three sides, so I can use any ratio I want. So I'll choose the sine ratio, which is equal to the opposite side, 20, divided by the length of the hypotenuse, 54. So 20 divided by 54 is equal to 0.3703. And if I wanted the angle, I would just take the inverse sine. So inverse sine gives me 21.7, which I'll round to 20. I'll round it to 22. So theta approximately equal to 22 degrees. So make sure you're using your approximation symbols because these are not exact numbers that we're getting for our answers. Some of these would have to be changed. Okay. Example 5. Solve for the angles in the following triangles, round to the nearest degree. Okay, so let's solve for the angles. If I look for this angle here, let's mark that theta. 20 is my adjacent side, and 25 is my hypotenuse. So the ratio I have to use here is the cosine ratio. The cosine ratio equals 20 divided by 25, the length of the adjacent divided by the length of the hypotenuse. So 20 divided by 25 equals 0.8. And to properly show that I'm looking for the angle, I'm going to say theta equals the inverse cosine of 0.8. 20 over 25 is 0.8. This is how you express that the fact that you're looking for the angle theta. So theta equals, if I do the inverse cosine, 36.86, or I'll round up to 37 degrees. Okay, now what if you're not given the picture of the triangle? You can draw it. Triangle EFG. Now remember, one of them has to be a 90-degree angle. So angle F is my 90-degree angle. Here's F. E I'll put up here, and then G I'll put over here. Lowercase g, which is opposite of angle G, is going to be over here, and that's going to be 24.2 millimeters. And E, which will be opposite of angle E, which is down here, and that's going to be 10.5 millimeters. And so here we go. I am going to find one of these angles. Oh, I didn't even find the other angle for the previous question. My bad. Well, let's look at 37 degrees. This is 37. The sum of the angles inside a triangle have to add up to 180. So my unknown angle up here will be 180 minus 90 minus 37, which is equal to 53 degrees. Okay. All right, so down here, let's look for angle G. Let's call that theta. And I'm going to use the tangent ratio because this is my opposite side, 24.2 millimeters, and the 10.5 millimeters is my adjacent side. So I can say the tangent of my marked angle theta is equal to the opposite side, 24.2, divided by 10.5. And that's going to equal the 24.2 divided by 10.5. So there's my decimal, 2.3047. So theta is going to equal to the inverse tangent of 0.20487. And instead of rounding, I'm not going to, sorry, 2.3047. Oh, my mistake. 2.3 2.3047. Okay. And to find that angle, I'm going to keep all these decimals in my calculator, and I'm just going to hit the inverse button to get my angle, 66.5 degrees, which I'll round to 66 degrees, or 67 degrees. So here it is, 67 degrees. Okay, and so that's going to be 67 degrees, and to find the other angle, I'll subtract that from 180, so 180 minus the 90-degree angle minus my 67 degrees is equal to 23 degrees. So that is angle E. Okay, one little note, whenever you have a triangle and you're labeling the triangle by its vertices A, B, and C, the lowercase letters used to denote the lengths of the sides. And the lengths of the sides will always be the opposite of my angles. So if angle B is over here, lowercase b will be across from that. If angle A is up here, lowercase a will be across from that. And if angle C is over here, lowercase c will be across from that as well. Okay, so that's our brief introduction to trig ratios, and I'm going to end this video.